Hello again. We have another session for MG5002 Engineering Mechanics. This week we will cover equilibrium of non-concurrent forces. Overview. This week's topic is about the equilibrium of non-concurrent forces. By the end of this topic, you should be able to describe what non-concurrent forces are, describe the concept of moment of forces or force, say what the total moment is for a non-concurrent force system in equilibrium, solve problems based on a moment of non-concurrent forces in equilibrium, apply moments and equilibrium of non-concurrent forces system to describe designing structure spots. And so please, if you can go through the pre-class activities, try to go and solve some of the examples here, required lesson equilibrium of non-concurrent forces. And before that, I really recommend you guys to open or download this equilibrium of non-concurrent forces notes so we can go through them. So when you download these notes, it just reminds you what we introduced last week. Last week, we tried to solve many different applications involve concurrent forces. We solved them using the equations of summation, algebraic summation of forces in the horizontal direction and algebraic summation of forces in the vertical direction. Now, the new things we will learn this week is how can we study the moment of force. The moment of force about any point is the magnitude of force multiplied by the perpendicular distance from the point to the line of action of the force. I will highlight this is really very important. It's always about the perpendicular distance from the point to the line of action of the force. So you will ask, which point are we trying to address? Is the point to the line of action, these things. So let's take this example. Calculate the moment of the 10 kilonewtons force about points A, B, and C, and this is the 10 kilonewtons. So if we try to solve this example, what I need really to do first is try to project this force perpendicular in that direction to determine where exactly this force will be lying or where it's going. So kind of, if I move this here, so it'd be exactly on top of it. This is the projection for it. And then if I do the same thing, I need now to find the direction of this force perpendicular on that way. So just make sure. So if you look carefully, that's my perpendicular. And then I need to add the other one here. Yeah. Then highlight, just make a disconnected line so we don't confuse ourselves. So this is my also another perpendicular. You see the angle here is divided to 90 degrees and 90 degrees. The total is 180, 90 degrees and 90 degrees. So that will be the first thing we're trying to understand. How can I transfer the 10 kilonewtons times the distance to A, or 10 kilonewtons to B, or the 10 kilonewtons to point C? That's the moment we're trying to achieve. So first of all, we determine where this force is acting in that vertical direction. Therefore, always the distance will be from that point to A, or from that point to B, or from that point to C. Now, mathematically, we need to determine the angle here between these two. Since this is a 45 degrees, definitely this one on that direction will be 45 degrees. So I'll write this angle, make it easy. Oh, see, didn't need that. I needed just a box so I can write the angle. Will be, if we say this is 45, and then using the equation, we can add the degree, and then we put this here. So this is my 45 degrees, right? Now, if this is 45, and this is going with an angle 90, so technically this is also 45, but at the moment we don't have any issues. We know that the length of this one, all of it is 2 plus 2 is 4 meters. So how can we find the distance? So I will say the first thing I need to define this one. If we call the first one D1, so let's write it as small letter D1. So this represents for me the first distance. And the second one here, we call it D2. So this one is D1 here, and D2 is the distance from where is the force acting to point C. Now, how can we find the values for D1 and D2? Let's try to solve this one in this side. So D1 equals to D1 equals to 4. That's distance from here to there. From this point to this point is 2 plus 2 is equal to 4. Cosine the angle 45. Now you say, why cosine? Because I'm trying to find D1. And I will insert the angle in degrees. This will be equal. So if I use my calculator, it's very easy. Cosine 45 is 7.707 times 4. That will be 2.8 meters. So that's D1 value. I will write it here for you guys, 2.8 meters. So in this way, you will understand, for some reason, this is when I accepted capital D. Now, after we found D1, the same thing, if I try to do it for D2, it's the same principle. D2, if you look carefully to it, it's D1 divided by 2, which is equal 2.8 divided by 2, and that will give you 1.4 meters. Now you say, why? Why is 2.8 and divided by 2? Because remember, this is 2 meters and 2 meters. So kind of it's half the distance. So if D1 is 2.8, this one will be half of that distance, which will be 1.4 meters. After we found that, now we need to write algebraic summation of the moment, because we want to calculate the moments of the 10 kilonewton force about point A. So I will go to the equation editor. I'll put it here. Just bring the equation editor here. And then I will choose algebraic summation. Here, the most interesting thing, how can we write it? M represent for me the moment about which point we say A. So I'm choosing to take or transfer this 10 kilonewtons about point A. And then we write the equation. So what do you have? You have force going in that direction vertical from that point to that point. So the force is 10 kilonewtons multiplied by the distance, which is 2.8. So that will be, if you multiply 2.8 times 10, will be 28 equals to 28 kilonewtons meters, because what you're showing here, that's the moment from here to that point is just the 10 kilonewtons times the distance 1. Now, if we try to do the same step for finding the moment, we repeat it about point B. What do you think the difference between A and B? If you look carefully, it's still the distance from that point to that point is equal to D1. Therefore, I will write the moment, so we can write it in an equation to make it easy for you, so you can see it, but in the future you don't really need to show all these things, because you just say they are equal because they have the same distance, and that will be equal to 10 times 2.8, because again we're transferring the 10 kilonewtons to multiply by that distance D1, which is 2.8, and that will be equal to 28 kilonewtons meters. Now, the same thing, we need to find the moment about point C. So we go again and we try to write again algebraic summation of forces. We make sure to selecting this script so I can have M, which represent the moment about point C. So what we're having here, the same force, which is 10 kilonewtons multiplied. Now we want to transfer this force from that line, this is the line of the force, to that distance stop till here, which is D2. D2, remember, we got D2, which is 1.4. So times 1.4, and that will be equal to 14 kilonewtons. Now you can say, hey, why are you doing it? We could simply, because we know D2 is half of D1, we could just divide the 28 kilonewtons meters divided by 2, and then you get the final answer. Both ways are okay, are acceptable, and that, but I'm showing you the different ways to find out. So if we try to summarize this question or the topic we're introducing, non-concurrent forces systems, the definition for its moment of a force is the first thing we need to introduce. The moment of a force about any point is the magnitude of the force multiplied by the perpendicular distance from that point to the line of action of the force. So that's the line of action. So if we want to say, what do you mean? This is represent for me the line of action of the force. This is very important. And if we get this example, we try to do the analysis, we find the line of the action, the distance from the line action perpendicular to that point. Distance from line to action perpendicular on that point, and then force times distance is equal to moment. And that's what we did. Always we multiply the 10 kilonewtons times, because we have 10 kilonewtons times the distance. Distance one time is 2.8. Or from here to B is 2.8 again, and from here to C it's half of 2.8, which is 1.4, and you get the answer. Moment is always force times distance, which means the unit newtons or kilonewtons times meters, depends on the force. Since we have the force in kilonewtons, so the answer will be kilonewtons times meters, distance also in meters. So this is the end of this video. I hope you enjoy it and you can see another one. Thank you.